we were looking at this particular video, and notice that I did not give this a title. I did not name this experiment. Shame on me. Let me see if I can name it. I don't think that I can. So it doesn't look like it gives me the option to rename. Dropbox, we can do it, but it's a task and a half. So I'm just going to go ahead and switch this over to table. And once I switch it over to table, I can share this table with Microsoft Excel. Okay, so now we want to go ahead and convert and edit. And of course, we want to put this not into our vectors folder. We want to go back to, let me see, where is that? I just had term 10, unit, initial velocity. So we want to make sure that we're saving this in initial velocity. I'm going to go ahead and call this something else. We call this initial velocity. Initial velocity. So I'll just save that. Now it's nicely labeled. Okay. And we go ahead and expand this. So now time, x, we have our x velocity and we have our y velocity. So let me see if I can go back to this particular figure here. And I want to point out what we need. What we need in order to solve for initial velocity here is going to be the displacement in the x direction and the time of flight here. Okay? And so in order for us to, we're going to find our displacement from the video. Okay, so that's cool. But if we're going to find our time of flight, which is going to go into this equation, we need our displacement in the y direction. We already know g. G is 9.81 meters per second squared. Okay? So if this is what we're about to work with. So notice we're not going to utilize the time that's produced from video physics. We're not going to utilize the velocities that are produced from video physics. So we can all but eliminate those things. So let's go here. See time, we don't need. So I'll just hide that. And then velocity in the x direction and velocity in the y direction, we don't need those. All we need is our x and our y. All right. And in the next video, we'll go about processing this data.